Hello everyone, this is our fifth device modeling MBP Python tutorial. In this video, we will show you a more complete project example with MBP Python script, which is the corner thinking example. In the previous tutorial, we explored data processing using the MBP Python APIs. In this video, we will dive into a more comprehensive example using MBP Python APIs for corner thinking. In the traditional way to twink corner model, we will manually perform each step within the MBP GUI. When switching to a new project, we need to reset all the steps. However, within the MBP Python script for adjusting the corner model, all procedures can be completed in a task group, making it easy to switch between different projects. In MBP, the corner twinking flow is quite straightforward, as outlined in this workflow. It starts by opening or creating an MBP project. Next, processing the data through a third-party software if your data is not in MEA format. Then, you will need to prepare the corner library. You can either generate the corner library externally or use the corner model tool within MBP to create a corner library with the typical NMOS and PMOS model cards. After preparing the corner library, use the libparser to load it, and then load each corner data file one by one, twinking the associated parameters as needed. Finally, check the results. The process for twinking the corner model within the MBP GUI window and using an MBP Python script is the same. However, using MBP Python can provide more consistency throughout the steps, and it eliminates the need to pre-process data outside of MBP. This entire workflow is fully automated and allows for easy switching between different projects. We implement several examples using the Python editor in MBP, which you can find in the demo project. In this example, we create a complete corner twinking workflow with 3 target parameters: VTHLin, IDLin, and IDset. As I mentioned earlier, the workflow for using the MBP Python editor to twink the corner model is similar to the process in the MBP GUI. Here, in this second step, rather than using third-party software to pre-process corner data into MEA format, we can directly convert it to a data frame and MEA format within Python script in the task group, as discussed in the previous tutorial video. Following this, we generate the corner library using the MBP Python API, which calls the corner model tool in MBP. Next, we create the boundary for the tunable parameter in an independent Python file defined in this workspace. You can also find how to call an independent Python file in a task group in a previous video. Then, the selected parameters for the 4 corners under each device will be extracted automatically. And you can observe the extraction process in the MBP main window. Finally, we will load the extracted corner library and review the final results. Next, let's explore some useful MBP Python APIs for corner twinking. In the corner module of MBP Python, there are 2 main functions: corner model, which is used for generating and loading corner libraries into MBP; generate corner lib, which calls corner model to generate a corner library using typical NMOS and PMOS models. If you have a corner library, you can use other 2 APIs. The load corner lib is used to load a whole corner lib into MBP, while the load single corner lib will load a specific corner library into MBP. The data process function contains the corner data handler class, which includes various useful functions for processing corner data. For example, the function generate DP data will convert data into a data frame format and saves it to a specific directory. In MBP, detailed instructions for these APIs are available in the help menu, which you can consult whenever needed. Alternatively, you can type the function name in the MBP Python editor. The details for that API will appear in the log panel when you click on it, as we explained in the first tutorial video. Now, let's dive into this example. For this corner twinking example, you can open it from the demo project and save it to your working directory. All the necessary data files and typical models are included in this example workspace. An existing MBP project file is included in the MBP project folder. The corner model in this example consists of two CSV files that we need to convert into data frame. The typical NMOS and PMOS models can be found in the model folder. All extracted corner libraries will be saved in the output folder later. There are 3 independent Python files that implement functions not directly provided by MBP. However, it is still easy to use the existing Python APIs, which offer many basic and useful functions to assist in building your own functions. Next, we can build the twinking flow in the TaskGroup. As mentioned earlier, this TaskGroup allows us to start by opening an MBP project. After that, we convert the CSV data format to a data frame structure using functions from the independent Python file loadCSV_func and generate DP data using the API generate DP data. We then generate the corner library and load it into MBP using the API function generate corner lib. Once we set the parameter boundaries, we can tweak the corner model for fast, slow, fast, slow, and slow one by one under each device. We can always monitor process in the MBP main window. Finally, we can review all the results here. From this example, you will find that using MBP Python script to build extraction flow offers more flexibility compared to the traditional methods. In the summary, MBP Python script can build a complete corner twinking flow with MBP Python APIs more efficiently. The whole twinking process has more flexibility within Python editor, and the flow will be easier to improve or reuse later. Thank you for watching.